Hi everyone. Uh, this time around we are considering position, distance, and displacement. To start with, let's quickly look at the definition of position. Position is the location of an object in a given direction with a reference point. Or you can say position is the point at which an object can be located with respect to reference point or origin. It is a vector quantity. Okay. Now, for instance, let's look at the Cartesian plane that we have here. We may say the position that we have here is 2 units to the east and 3 units to the north. How do we come about this? How do we know that it's 2 units to the east and 3 units to the north? We only know that when we make reference to this origin. So that is why position is defined as a location where object can be found in reference to the origin. And we can as well refer to this position as a 3 units to the west and 1 unit to the north when we make reference to this origin 0, 0. So that is the essence of the origin that we have in the definition of position. That is the point to be made here. And position is a vector quantity because position has to be in a specified direction in reference to the origin. Okay, moving away from position, let's quickly look at what distance is. Distance is how far an object has traveled. It is a scalar quantity and it is measured in meter. Mathematically, distance is average speed multiplied by time. Distance is average speed multiplied by time. We are going to make reference to that when we start our calculation. Okay. Before now, probably what we are familiar with is a distance. The term displacement is not a common term. It's only a term that is very, very important in physics. Most time, some people describe displacement as distance as well, but there's little difference between displacement and distance. What is displacement? Displacement is the change in position of an object in a given direction. Change in position of an object in a given direction. So that makes a position to be quite different from distance, because distance is how far object gone, and in the term of displacement, the path taken by the object to move from one position to another is not taken into consideration. The only thing taken into consideration is just the change in position. So we're going to lay more emphasis on this when we get to the calculations of distance and displacement. Okay. Also, mathematically, displacement can be described as average velocity multiplied by time. You can see that one in the equation that is shown on the screen here. Sorry, this equation that is shown on the screen. Yeah, okay. Now let's quickly consider the first example that we have here, because basically what we are looking at in this video is just solutions to some past questions on displacement, position, and distance. And with that, we'll be able to know clearly the distinction between the displacement and distance. Okay, the first question is, during a race on the level ground, Sandra runs with an average velocity of 5 meters per second to the east. What is the Sandra displacement after 120 seconds? With what we have here, we have the velocity of Sandra to the east, and we have this total time spent by Sandra while running. So we can make use of this equation here, where we have displacement equal to average velocity multiplied by time. Using that, we have the value of our displacement to be equal to 600 meters for that particular question. Let's consider example 2. In our example 2, a man walks 12 kilometers due east and then 5 kilometers due north. We have to determine the distance covered by the man and his displacement. Okay, if we are to represent the expression of the question diagrammatically, a man walks 12 kilometers due east. then 5 kilometer due north. We can see that the two paths stated in this question, they are perpendicular to each other. So that is what we have in this diagram here. We have to calculate the distance covered and the displacement. Remember the definition of the distance. Distance is how far an object will have gone. So considering this fact, how far this man walks from the initial position to the final position is what we call distance, and that is 12 kilometer to the east plus 5 kilometer to the north, and that is what we have here. And we have 17 kilometer for the distance. But in the case of displacement, the initial position is here and the final position is here. And according to the definition of displacement, displacement is change in position, just change in position. The path taken by the object changing position is not taken into the consideration. It's just the change in position. So we can consider this part as our displacement from that definition. And mathematically, looking at the path taken, it represents a right angle triangle. So our displacement can be calculated using Pythagoras theorem. And that is what we did here. And our displacement is equal to 13 kilometers. Remember Pythagoras theorem? Hypotenuse square equal to opposite square plus adjacent square. This one represents hypotenuse. This is our opposite, while this is our adjacent in that case. Okay, our displacement is 13 kilometers. But remember, displacement is change in position in a specified direction. So we need to also calculate the direction. And the direction of the path of the man from initial position here to this final position is represented with this theta. And we can as well use SOHCAHTOA to find the value of the theta. So tan theta from the word TOA, which represents tan, equal to opposite over adjacent. We can say tan theta equal to opposite, which is 5, over adjacent, which is 12 kilometers. And that will give us this. From there, we can get the value of our theta, finding the tan inverse of 0.4167, and that will give us 22.6 degree. And that direction is north of east of the initial position. So that's why we stated that displacement is 13 kilometers, 22.6 degree north of east. So that is how we state displacement. When we are talking about displacement being a vector quantity, you are going to state the magnitude and also state the direction, because this is a vector quantity. But in the case of distance, we only mention the magnitude because distance is a scalar quantity. Take note of that. That's one of the distinctions. Distance is a scalar, while displacement is a vector. Another distinction stated here is that distance is how far objects will have gone, while displacement is change in position in a specified direction. Okay, let's consider the third example. In our third example, we have a figure that is showing the path of an object that moves from point A to B. We are to determine the distance covered by the object and its displacement. And if you look at the path very well, the path represents the semicircle. As you can see, the path taken from A to B represents semicircles. So finding the distance simply means how far the object will have gone, the path taken by the object, the total path taken by the object. And considering that being a semicircle, we are going to take something into consideration that you did in your mathematics, which is circumference. And circumference of a semicircle is pi r. Remember, circumference of a circle is 2 pi r. And semicircle is half of a circle. So if you divide this by 2, you're going to have pi r. So that is how we arrive at that. So using the value of pi given in the equation 3.14, multiply by the radius of this circle, which is 10 meters, we have the value of our distance to be 31.4 meters. Okay, remember distance is a scalar quantity, so we are not going to state the direction because we have multiple directions from here, from here, from here. So we are not stating the direction. But in the case of displacement is change in position from origin to the final location. And that represents the diameter of this semicircular part, which is equal to 2 multiplied by the radius. And that is what we have here. And the value of our displacement equal to 20 meter east of A. You can see that 20 meter east of A. So that is our displacement. Okay, moving away from that, let's check. We have one or two more examples. Okay, in example 4, we have a lorry that travels 10 kilometers northwards, 4 kilometers eastward, 6 kilometers southward, 4 kilometers westward to arrive at a point T. We have to determine the distance covered by the lorry and the displacement. Okay, let's start. 10 kilometers northward, this part, that is 10 kilometers northward. All right, 10 kilometers northward. According to the question, we have 4 kilometers eastward, and that is represented this way. 6 kilometers southward, that is represented this way. And 4 kilometers westward, that is represented this way to arrive at point T. To find the total distance, remember the definition of distance. Total distance is how far object will have gone. And that represents this 10 plus this 4 plus this 6 plus this 4. And that is equal to 24 kilometers. The total distance covered by the body equal to 24 kilometers. And when it comes to displacement, we realize that the displacement is just from this initial position to this final position. So our displacement will be this part, sorry for that, this part minus this part, and that will give us a displacement from here to here, and that is what we did here. That is 10 minus 6, and that is 4 kilometers north of the origin. Our displacement is 4 kilometers north of the origin. Okay, let's consider the last example, which is example 5. In our last example, the question says a boy travels from point A to D and later to point A. That is point A to D and later back to A. Okay. Now, as shown below, we have to determine the distance covered and its displacement from A to D. Also, the distance covered and displacement from A back to A. Okay, the boy moves like this. When we take distance into consideration, remember distance is how far object will have gone. So distance covered from A to D will be equal to 3 meters plus 5 meters plus 3 meters. Remember, if this place is 3, this distance will also be 3 meters. Okay, so that is how we arrive at that. And summing it up, we have the distance covered from A to D as 11 meters. Okay, now for the displacement from A to D, displacement is just changing position. This is initial position for that, and this is final position, and that is just 5 meters to the east of the origin, or to the east of A. A is the origin. So that is what we have in our displacement. Okay, for the second part of the question, that is the movement of the body from A to A, the total distance will be 3 meters to the north, plus 5 meters to the east, plus 3 meters to the south, plus 5 meters to the west. And that is what we have here. And that gives us a 16 meters. In the case of displacement, the object arrived at the origin. So which means the displacement is 0 because the position is not changing at all. The object moves around and comes back to the origin. So the displacement will be 0. That is, whenever object moves and end the journey at the origin, the displacement will be equal to 0 meter or 0 unit. So from all the examples that we've treated so far, there's something that is constant. Displacement is always less than the distance. So we can as well define our displacement as the shortest possible distance between two locations. Shortest possible distance between two locations. That's another way of expressing our displacement. So from what we've done so far, we can bring out like 3 or 4 distinctions between displacement and distance. First, distance is how far object will have traveled, while displacement is the change in position in a specified direction. Distance or is longest or the total path traveled or covered by the object, while displacement is the shortest possible distance traveled by the object. And you can see from this second example, you can see this from the second example, or from all the examples, the second distinction is established, which is a shortest possible distance between the origin and the final destination. And in the case of displacement, direction is specified. Why in the case of distance, we may have more than a specified direction. That is, we may have multiple directions. So with that, we can state the distinction between distance and displacement. And by now, I want to believe we can calculate the distance and also the displacement. In case there's anything that is you're still finding difficult from what we discussed so far, please feel free to drop any of your question or your suggestion in the comment box to be attended to. And please, just before I go, if you're yet to subscribe to this channel, please do, so that you have access to our subsequent videos. Please do that. And if you're interested in having all the materials that we have in this video and all our videos, we've compiled all the materials together in form of e-note. Just reach out to us through any of the number that will be displayed in this video. Just reach out to us and we'll get the note across to you. That is all the materials that we've used in preparing all the videos that we've done so far, including this particular video. We compiled all the materials together, and it's a single document. It's a comprehensive e-note that is very, very useful for students at this level. Okay, just before I go, let me quickly talk about one of the best physics practical book that you can see around. I call it one of the best because what the problem that this book can solve. The book is structured to undo every problem that has to do with practical for school candidates, that is WAEC and NECO candidates, and also for private candidates, that is GCE candidates. We have normal practical exercises in this book and also alternative to practicals for GCE and NECO GCE candidates. And in addition to that, we have practical exercises for Cambridge IGCSE candidates. So if you're interested in this book, please feel free to contact us using the number on the screen, or if you are interested in the e-note that we normally use in all our videos, just reach out to us using any of these numbers or the email on the screen. Or if you are interested in the soft copy of this REVAMP Physics Practical book, you can get it on this link. Just click on the link, you get the soft copy of REVAMP Physics Practical book. And also, we do offer some services like online tutorial for students preparing for any of the examinations shown on the screen. If you are interested in any of them, please just reach out to us using this number displayed on the screen, and we'll know how to go about it. And once again, please, if you are yet to subscribe to this channel, please do, so that you have access to our subsequent video. Thanks for watching.